Good morning, students. Good morning. Are you hear my voice? Anyone? Can you please respond? Whether my slide is visible?
Yes, sir.
Okay. Okay. Good morning to all. Today my topic is lecture number 20, double revolving field theory. Double revolving field theory. So what means by double revolving field theory? It is a concept which produces a rotating magnetic field in the induction motor. Normally, if you take three-phase induction motor, it is only rotating in forward rotating magnetic field. Okay, suppose suppose if the machine is running in backward due to some misalignment in the machine, that is problem. Okay, so then we have to apply brake mechanism. Then automatically the machine goes to forward. Okay, there is a concept in three phase. But when it come to the single phase induction motor, the rotating magnetic field will be produced in both forward and backward. Why it is forward and backward means we are giving a single phase supply. Okay, single phase sinusoidal supply. This top portion, you see, okay, this portion, the positive quadrant 0 to pi, called it as forward rotating magnetic field. Okay, and this bottom line, okay, the range is pi to 2 pi, okay, 180 to 360 degree. This is nothing but, this portion is nothing but backward rotating magnetic field. Okay, so in forward rotating there is one flux is produced, in backward rotating also there is another flux is produced, that is one is phi 1, another one is phi 2. Okay, so this concept is known as double revolving field theory. This concept is known as double revolving field theory. Then, now we will see the introduction about double revolving field theory. So when you see this diagram, okay, so in this diagram, the y-axis is the flux. Okay, it is a magnitude. Okay, it's a magnitude, and x-axis is the theta. Theta means angular rotation, where theta equal to omega t, where theta is an angle, omega is the angular rotation, where omega is 2 pi f into t. Okay, where f is nothing but supply frequency. In terms of time, we know fs is inversely proportional to time. So 2 pi into t divided by t. So t and t will cancel. We will get 2 pi. Okay. So this it's nothing but pi. This is 2 pi. Okay. So from 0 to 2 pi, it is nothing but one cycle. Okay, one cycle. Okay, so t equal to 1 by f. So how much of frequency in our country? So it is 1 by 50 equal to 20 milliseconds. That is 0 to pi off cycle, it is 10 milliseconds, and another off cycle is 10 milliseconds. So total it is 20 milliseconds. Are understand my point? So this, in this half quadrant, the angle is 180. Now when I come to this diagram, you see this is a single phase motor. This is the if you take a motor and open it, you will see these parts. Okay, this parts which we are seeing, it is a cover. Okay, and it is a cover. You see in the cover only the nameplate detail of the motor will be printed by the manufacturer. Inside the cover, okay, there will be a slots are available. That is nothing but stator. Okay, so in stator you see a line will be there, right? Okay, this line, okay, this line, this portion, it is nothing but a slot. Okay, it will be shorted. Okay, it will be shorted, and outward end of the slot is nothing but it is the windings. Okay, in the winding only, in the stator only winding, we have to set synchronous speed. Jibran, Karthik, Kevin, it's not possible to enter into the class at the proper time. You people are just disturbing my class.
So I didn't receive your mail. I did message you at 10 o'clock also on WhatsApp.
Okay, ma'am. Okay, okay,
That's why I was late for the
okay,
class.
okay, okay, okay. So here in stator winding, you see NS equal to 120 Fs by P. Okay, so in stator winding only we have to set the synchronous speed. Or understand my point? This is nothing but stator. It is a stationary method. Okay, the outward structure of the stator is a stator frame. Okay, it's a cover which protect our stator winding. Otherwise, what happened without this frame? Okay, if you give the if you apply the voltage or current, definitely it will be safety precaution. Okay, safety precaution, it is a question mark. We have to protect our winding. Okay, this lines you are seeing, right? Okay, this orange color line. Okay, these lines are the insulation. Okay, maybe a porcelain materials or paper, they will use the insulation, you see here inside. Okay, then inside, okay, inside the stator they will insert the rotor, and you see the structure, the rotor, it's having a slanting lines, you see. This is nothing but this slanting lines called as screw cage rotor. Screw cage rotor. Okay, this is nothing but screw cage rotor, and inside the screw cage rotor there will be a shaft is mounted. Okay, this is nothing but, okay, shaft. This is the shaft. Okay, we have to just insert this rotor and shaft, okay, in the proper dimension. Okay, in the proper dimension. So there is no connection between the stator and rotor. There is just a gap we have to make. Okay, like our car wheel and the body cover is there, right? There is a small gap will be there. Okay, like that we have to maintain. That is nothing but R gap. Okay, so this is the general. Okay, now we have to give a single phase supply to this motor. Okay, you see a wire, you see. Okay, so this wire we have to give a single phase. Here only we have to give single phase supply to this stator. So once you give the single phase supply, what happens? If you give the single phase supply, there will be a current is flows in the stator winding, then the flux is produced. Then a flux is produced. That is nothing but rotating magnetic field. The flux is other name called as rotating magnetic field. Okay, rotating magnetic field. So this flux, which I am going to explain in double field revolving theory. Okay, now you see this diagram. Okay, once you pass the voltage, once you apply the voltage, with a single phase supply, the current flows in the stator winding, then the flux is produced. So this flux here I represented. Because our motor will be rotated in the 360 degree, because it is a circling structure, right? It is a circular. It rotates at how much angle? 360 degree. Okay, 360 degree. Okay, now you come to our waveform. Okay, now I mark f.1 as a initial stage. This 90 degree. Okay, this is 90 degree. I mark it as 2. Then this point is nothing but 180 degree. Okay, 3. And this another point I mark it as, it is 180 divided by 2. Okay, it is 220 degree, and this is 360 degree. Okay, this is a dimension. Okay, now the one point which I set it here in the motor, this is the origin. The motor starts moving from 1 to 2, 2 to 3, 3 to 4, then 4 to 1. Okay, then 4 to 1. When you start, okay, when the waveform starts moving from 1 to 2, because waveform means current. Okay, current, electrons. Okay, once the current is moving from 1 to 2, automatically your rotor, it starts moving from 1 to 2. Okay, 1 to 2. Okay, so there will be a flux is produced. Okay, this 1 to 2, understand or not? This is nothing but counter clockwise direction. Okay, this portion is nothing but counter clockwise rotating magnetic field. Okay, forward rotating magnetic field. Okay, then 2 to 3, you see here again the waveform, it starts from top portion and it will be move downwards to 2 to 3. Okay, that is nothing but forward clockwise direction. Okay, forward clockwise direction. Are you understand my point? Are you understand it? Okay, in the waveform, because this is nothing but it is a positive quadrant, this is negative, because in our graph paper it is positive, and negative. Okay, now this 1 to 3, it comes in the positive quadrant. That's what I am mentioning. When your current value moves from 1 to 2, then your rotation is forward clockwise direction. Please see this diagram also. Okay, this diagram also please see. Then when the waveform, it starts moving downwards from 2 to 3, then it is called as forward clockwise direction. Forward clockwise direction. Or understand my point? Okay, so like that, when the current value starts moving from 3 to 4, then again you will get another direction. Since it is minus, it is for backward counterclockwise direction, and 4 to 3, it is nothing but backward. B stands for backward. Okay, backward. F stands for forward. F stands for forward. Okay, this 3 to 5 is nothing but backward clockwise direction. Okay, block clockwise direction. So in forward rotating magnetic field, there is a flux is produced, that is phi F. Okay, in backward rotating magnetic field, there is a flux, it is phi B. I want to see who is that person is coming. Previously I clearly mentioned, okay, the lecture will be recorded. Okay, it is recording, but some of the students still they are not understanding the difficulty which we are conducting through online. since you are in the house and it's not possible to get into the class at the proper time. Now operation. Okay, the theory content has already explained it. Okay, first step, when you give the supply, the same diagram only representing a slide number 4. Okay, 0 to this point, 0, this is marked as 1, 2, 3. Okay, 1, 2, 3. During that time there will be a 5 f is produced. Okay, 3, this is 4, this is 5. Okay, this portion there will be 5b. Okay, there will be 5b. So there are 2 fluxes are produced in one cycle. Okay, 2 fluxes are produced in one cycle. What are the fluxes? One is 5 f, another flux is 5 d. Okay, now these 2 fluxes will be opposite to, that is when you give the that is, this is a motor. Okay, this is a motor, this is the windings are there, you are giving the supply, you are giving the AC supply. Once you give the AC supply at starting, at start portion, okay, at the starting stage, what happened, the 2 fluxes are produced. These 2 fluxes are opposite to each other. Okay, these 2 fluxes are opposite to each other. Okay, so this is overall, it is 360 degree. 360 degree. You see, the one flux, it's covered off of the portion, another flux is covered off of the portion. So therefore, phi f, which is equal to phi b, which is equal to phi 1m by 2. Phi 1m is nothing but a magnitude. This m stands for magnitude. Okay, magnitude. Okay, so phi f equal to phi b, which is equal to phi 1m divided by 2. Okay, when this phi 1m divided by 2 will be produced, when your motor at starting stage. Okay, at the starting stage, you will get a equal flux will be produced in phi f and phi b, as well as, but it is opposite, it is opposite to each other. Okay, due to this opposite directions, you will get a magnitude of flux is divided by 2. So therefore, a resultant flux phi r stands for a resultant flux equal to 0. Phi r stands for resultant flux is equal to 0. Okay, are you understand my point? This is my first step. When the motor at start, there are 2 fluxes is produced, phi f and phi b. Phi f stands for forward flux and phi b stands for backward flux. These 2 fluxes are in opposite to each other at starting stage. Therefore, a resultant flux will be 0 because phi 1m is divided by 2. It is half of the portion is covering, so I put it divided by 2. Then now at 90 degree, okay, at 90 degree, what happened? Okay, at 90 degree, actually this is the waveform, this is 0, this is 90. Okay, at 0 degree only, okay, it is a starting point. At 0, it is a starting. At 0, the resultant flux is 0, phi r equal to 0. Okay, when the flux, it is at 90 degree, okay, it is at 90 degree, then these 2 fluxes are now pointing in the same direction. Okay, you see, same direction. Okay, then we'll get phi 1m by 2 plus phi 1m. This is nothing but phi 1m. phi 1 m. Okay, so this portion is nothing but phi f, this portion is nothing but phi b. Okay, phi b. Okay, when 0 to 90, the waveform is, it is phi 1m by 2. Okay, and from 90 to half of the portion, okay, to 10 degree, like that, this portion, it is, it is phi b. Okay, it is phi b, phi f and phi f and phi b. Are you understand my point? Okay, 0, 90 plus 180 degree plus 90. Okay, 180 plus 90. Okay, then you can consider this also 0, this is also 90. Okay, so in forward you have to take 0 to 90, you will get phi 1m by 2. In backward also you are taking 90 degree, phi 1m by 2. So if you add both, you will get 2 phi 1m by 2, then 2 and 2 will be cancelled, you will get phi 1m, phi 1m. So therefore your resultant flux equal to magnitude of flux. Okay, resultant flux equal to magnitude of flux. Okay, please take down at starting stage, at start 0 position, 0 degree, at 0 degree phi r equal to 0. Okay, at running, because now you are giving the voltage, slowly the current value will be increasing it. Okay, so at running, the rotor is running, right? So due to that, it will be at 90 degree, at 90 degree phi r equal to phi 1m. Okay, this one stands for single phase. Okay, this one stands for single phase, m stands for magnitude. Okay, m stands for magnitude. Okay, the theory is already explained it. Now due to this double field revolving, there will be a torque and speed. Okay, in x-axis it is the speed and slip, y-axis it is the torque. Okay, y-axis it is the torque. Okay, at 0 degree, because now the motor is not running, so your slip value equal to 1. Okay, and n equal to 0, n equal to 0. So during that time there will be a torque is also be 0. Okay, at s equal to 0, n equal to 0, the torque is also 0. So single phase induction motor is not self-starting. However, if the rotor is given initial rotation, that is, if you apply the voltage, then the motor is slowly, it will be start running it. Okay, so because of this, the value, due to the increase in the speed, the value of the torque is also increases. You see, it is also increases, it is also increases slightly, and in which the rotor is initially rotated and the motor starts rotating in that direction. Okay, this positive is nothing but forward. Then in reverse it is also be a same. Okay, in backward the same concept, it will be a return back. Okay, so this positive, it is nothing but forward torque, the negative region is nothing but backward torque. Okay, this is backward torque. Okay, in forward torque there is a forward flux is produced, in backward torque there will be a backward flux is produced. Are you understand? Are you understand? This is the torque speed characteristics of induction motor. And you see the shape also, the shape will be equal. Okay, it will be like a hyperbola shape, it will be equal. Why it is equal means we are giving a balanced supply. Okay, positive is also 230, In negative also we are giving 230. Current here it is 5 ampere, means here also it is 5 ampere. Both are same. Okay, it will be a balanced supply. Okay, due to this balanced supply, we are getting a proper torque speed characteristics. Okay, this is one 5-mark question. Okay, sketch the torque speed characteristics of single phase induction motor and explain in detail, means you have to draw this diagram and explain these 2 points. That is more sufficient for 5-mark question. Okay. Okay, these are the theories already explained it. Okay, this one is also mentioned it. Okay, why single phase induction motor is not self-starting? Actually, this is one of the interview question. Okay, in most of the core companies they will ask this question. Okay, this is a basic question. Okay, why the induction motor is not self-starting? Why means there are 2 fluxes are produced in this single phase induction motor. These 2 fluxes it covers half of the portion. Okay, 5m by 2 portion. This 5m by 2 for forward, minus 5m by 2 for backward. Okay, so because of these 2 fluxes, the induction motor is running in opposite to each other, so it's not possible to operate the motor in self-starting mechanism. But to make the motor in self-starting mechanism, if these 2 fluxes it will be cancelled, then it is possible. It should not be cancelled actually. If it is not cancelled, then it is possible. But here it is cancelling it. Okay, 5m by 2 minus 5m by 2 are cancelled to each other. Then only your net torque is produced. Then only the starting condition is 0. Because of this, induction motor are not self-starting. But 3-phase induction motor are self-starting. In 3-phase there is only one flux is produced. Only one forward flux is produced. Okay, I understand this point. Okay, the topic is very simple. Okay, so please try to understand.